So predict. So we don't have an ability to capture and analyze data from the future. However, okay, there's a way to predict the future using data from the past, right? And that's basically predictive analytics, and organizations do it every day. So and some of the examples would be uh, I'm sure all of you basically shop uh, at, uh, at Amazon, right? So let's say you're shopping at Amazon, and they basically have assigned you a customer lifetime value. For example, depending upon how often you buy and how much you buy, right? You have a certain value assigned, and they don't know how they. I think Amazon probably is probably not as good an example because they have a subscription model where you basically pay an annual Prime membership fee, right? But some other companies like say Nike, right? They might actually have a lifetime value on you, saying that okay, this customer is worth this much, so this is the amount of money I'm going to spend on this customer for promotions, right? So there's this way to sort of calculate that as well, right? And we know that what is the next best offer or product recommendation, capabilities of prediction of a product or a service that you likely are going to buy, or in case of things like say Netflix, right? What are you going to watch next, right? So that's an example of prediction, right? Uh, Forecasting next quarter sales, okay, that's pretty much a given, right? Uh, let's say digital marketing models to determine what ads to place where and what publishers to cite, right? That's again a little bit of prediction involved. Employee retention, recruiting the best people. That is where also a little bit of predictive analytics work, where you're going to use what has worked in the past to predict what is likely to work in the future, and then when you get the next set of candidates who sort of match that profile or that set of combination of variables, then you basically know it's going to be a good hire or not, right? So that's just a little bit of the flavor of where you can use predictive analytics, and the fundamental, and of course that's true for everything we deal with data, but the need for good data is paramount, right? So lack of good data is the most common barrier to sort of organizations seeking to employ like predictive analytics, right? And to make predictions about what customers will buy in the future, or how do I drive down costs, or for example, like you need to have good data, right, on what they are buying, which may require, in case of what customers are likely to buy in the future, right? What are they buying, which may require like a loyalty program, or at least a lot of analysis of their say credit card activity, right? What they have bought in the past, and the attributes of those products. What kind of attributes basically apply to the products they bought? So it's basically like an attribute based prediction, and it's often more accurate than say the people who buy this would buy that as well, right? Because you're basically honing down in this personality type of a situation where you are sort of identifying this customer as as has some kind of a demographics attributes like age, gender, residential location, income, socioeconomic status, and all those things, right? So that's so having good data is basically a fundamental thing to running good predictive analytics, right? And of course statistics, right? And so regression analysis is what we're going to cover in its various forms, is the primary tool that organizations use for predictive analytics, right? So it sort of goes like this, right? An analyst, or it could be you, right? Hypothesizes, okay, sorry for that, hypothesizes that a set of independent variables, say gender, income, visits to a website, are statistically correlated to with the purchase of a product, right? Which is basically the dependent variable for a sample of customers, right? So the analyst then, or the you, okay, which you are the analyst, right, then probably perform some kind of a regression analysis to see how correlated each of these variable is. And that usually requires some kind of iteration to find the right combination of variables and the best model and all those things. And it's an iterative process to get to that right form of that model. But let's say you succeed and find that that set of variable in the model that is important in explaining the product's purchase and sort of drive up sales, right? So using that model, that you can basically use the coefficients which you can derive of that model, and sort of play around with that and see what level of that variable basically affects purchase behavior, right? And you can sort of create some kind of a scoring mechanism saying that, okay, what is the likelihood of that purchase if I tweak this variable by this amount, right? So this is a very simplistic way of looking at building a predictive analytics model, right, for customers who weren't in the sample, right? So basically, you're going to take what you have built a model on the customers who were in the sample, and you're going to infer it on customers who are not yet part of that sample, so that you can sort of gain more market share, right? Uh, and So that's the statistics part of this, right? And so let's say you have this data set. So let's say you're a store manager, try to predict next month's sales, right? So there are dozens, probably even hundreds of factors, that like weather and like whether a competitor is offering a promotion or not, right? Or can impact your sales, right? So regression analysis, just to go back to that, is sort of it's a mathematical way of sorting out which of these variables do indeed have an impact, right? It answers questions like what factors matter most, right? What can we ignore, right? How do these factors sort of interact with one another, right? And most important, how certain are we about the validity of these factors being included in that model, right? So how does it work? So you gather data, right? You on the variable in question. Let's say in this factor, in this case, you are sort of gathering data on the effect on sales of rainfall, right? Say rainfall. So somehow you have this x variable, which is rainfall, and the y variable is your sales, and you see this. You start plotting and you see this clear and plotting. Okay, visualization is where you're going to find out whether there is a relationship or not. Most of the time. Okay, so you glancing at the data, you probably notice that the sales are higher on days when it rains a lot, right? When it rains a lot, so that's interesting to know, right? But by how much, right? Do you know how much you'll basically end up selling if it rains 3 inches versus say if it rains 4 rains versus say if it rains 4 inches, right? And that's where you start building some kind of a model, right? So the so you and there is a little bit of math behind as to how you come up with this regression line, but it has a slope which is varying at 10 per unit of rainfall, and that has an influence on your sales. Okay, and so that's the best explanation, and you can see that the line doesn't fit each and every data point, right? So there is a little bit of error in your model around that, and that's where your error term is, right? And the error term, so basically you're just starting off with this rainfall, but let's say you include other factors on the right hand side, and you have multiple different x variables, right? Like promotions, competitive landscape, and so, and you see that your error term gets reduced and your model becomes more and more accurate, right? But what you have to watch out for is, and I think I briefly alluded to in the previous lecture, where you don't want to overfit your model to your data, right? Because it might work within that sample, but it might not work outside of that sample. So you want to sort of watch out for this balance between overfitting and underfitting, which we are going to cover later. Okay, at least the math part of it later, right? So you want to watch out. Okay, and uh, but that is you might be tempted to say that, okay, say the rain, but did the rain cause an impact on sales? Okay, but is that really the case? Did rain actually cause an impact on your sales? If you happen to be in the umbrella business, okay, maybe true, but that's not probably the case. There might be other factors, right? And that's typical when you run a model, right? So you want to make sure that you're not you're not just making a conclusion or using one factor, saying that, okay, rain caused my sales to increase, right? Uh, uh, what else? Okay, we covered that. uh, and going back to the range, so basically the you don't want to include factors which are basically nonsensical, right? So you want to have some kind of a causality, right? You want to make sure that there is some causal relationship between the variable you're going to sort of explore and its impact on the outcome variable, right? So you can't make assumptions or try to fit your theory to your data, right? So you have to go out and see what's happening in the real world. What's the physical relationship between that's causing that relationship, right? So the goal is not to figure out what is going on in the data, but what is going on in the real world, right? And a lot of the times we get tempted into sort of fitting your data to uh, coming up with a theory after you have seen the data. That's the backward looking way of looking at it, right? So don't let data replace your intuition, right? So ask if your results fit your understanding of the situation of the nature, right? And you need to pair your analysis with study of the real world as well, right? So and that's where uh, 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 that's where a little bit of uh, uh, this understanding of your business comes in, right? Or whatever application you're working on, right? And there is this thing by I think it's in The Power of Habit, right? Charles Duhigg, in his book The Power of Habit, basically uh, that that people establish strong patterns of behavior that they usually keep up over time. But sometimes, though, they change those behaviors, right? And the models that were used to predict them may no longer be valid, right? So the basic assumption of a building a predictive model is that the future will continue to be like the past, but that might not be the case, right? So that the fact that the profile of that customer you were modeling has changed, right? Might make your model invalid, right? Uh, and sometimes just the model becomes invalid just to the nature of time. So if the model was created several years ago, it may no longer be accurately predicting current behavior, right? So and the greater the time elapsed, the more likely it is that the customer behavior has changed, right? So take for example Netflix. Some of the older models, right? For example, that were created in the early years of their existence, and they had to be retired, right? Because later users were substantially different, right? The pioneers were more technically savvy, more technically focused, and relatively young. But the later users were basically you and me, right? Everyone, at least me, okay, not you, okay. And and another reasons why a model may not be valid is if the key if a key variable from the model is sort of missing, right? Or if it has changed substantially over time, right? And that's basically and I'm not sure how many of you have lived through or I'm sure you probably have lived through, but how many of you have intimately experienced that financial crisis of 2008 2009, right? Where the banks were predicting the behavior of these mortgage customers, right, with the assumption that home values never declined, right? That the home prices never fall, and they kept on rising. And they will always rise. And when they did start falling, basically all hell broke loose, right? So basically, their models were not predicting the fact that home values will ever decline, and that was a major blunder, which hopefully I think these banks have learned to not sort of repeat that same mistake. So so even with this, it's pretty amazing that that we can use analytics to predict the future, right? So even with this, all these caveats, even with this, all this quote unquote situations where models can go wrong, but things do work amazingly well, right? So all that is needed is to get the right data, build the right type of statistical model, and be careful about the assumptions, right? So some of the questions you should have answered to, I think we covered a little bit of that before. The source of the data you use in your analysis is the sample representative of the population, which is again the same thing. You don't want to be studying the wrong sample and inferring on the wrong population, right? Are there outliers in the data, and what assumptions are behind on the analysis, and are there conditions that could make the assumptions invalid, right? So these are some of the things on prediction. We are going to cover a lot on predictions later in the later lectures, but just to give you a flavor of as to why predictions, and the perks and the benefits of predicting in terms of not only getting more customers, being able to let's say you're in the sensor world, right, and you're dealing with an IoT device, right, and basically IoT device, you're basically going to predict with a bunch of variables, bunch of parameters you're measuring. You're going to predict something to be happening, right, and you want to sort of use some of these techniques here to sort of build a robust enough model where it does the job you're expecting it to do, right? So that's a bit on predictive analytics, right?